we will make the pattern display. Before we finally can read out various patterns, not just the first one, we should set up the graphical user interface for that. This SDL call refers to the upper rectangle that we use to navigate through the pattern display. This first loop creates the rectangles for every pattern that we might add to our song. Please note that we will just show 10 patterns that are next to our current position. So if we have more than 10 patterns, they will be hidden depending on which position our marker is. Now we set up the same old variables that we use for every call of the text processing unit. We will draw our pattern nominator numbers onto our rectangles. We read the pattern nominator numbers from our pattern counter array that we will also use to tell the software which pattern from the audio commands pointer dataset should be read. It also gets the numbers for our pattern nominators from there that we will convert to hex numbers and display them as hex numbers. Here we send the first hex number to the text processing unit that proceeds to draw it on the screen. The first jaw position pointer carries the information on which position of our ROM we read out our hex numbers. We already successfully implemented the row counter. I will show you via a print instruction that it works properly if we move the cursor via arrow keys. Let's see what happens. Here you can see the pattern display. Before we are going to implement the function to add new patterns, we need to get our GUI ready for that. As you might remember, this function was part of our right-click menu, so let's try to set that up. I guess there are more elegant ways to put stuff into an array. I had no time yet, everything related to the GUI was done in a rush. The highlighting position variable defines which text in our text field is being highlighted in black while the field itself is being drawn white. Now let's handle our mouse interrupt in the process input. If the 8th bit of our bit mask is set, the right-click menu will appear. If this mouse coordinates related condition is met, the window of the menu will stay open. This loop defines where the text field is being highlighted. After drawing the menu window, we call the create right-click menu text function that we coded a few minutes ago, and let pre-process it the text that we want to put on the screen. Let's correct a few mistakes. The first char position pointer points to the first characters in our read-only memory string that we set up in one of the first videos. Let's compile and see what happens. Our next task is to build a function that allows us to create new patterns. At first anything graphical related, afterwards all stuff on the backend side. Don't mind the variables copy data x and y and copy start x and y. I just want to include them now for the reason I might won't forget them later when I attempt to implement the copy-paste functionality. Okay, now let's build the function. When I composed one of my songs, I had some trouble related pattern 1A, which would be pattern 26. I'm still saving all my music files into text files. The file loader reads the ASCII number 26 in the Windows system as end of file command. So when I tried to load a song, it crushed any song that had more than 26 different pattern nominators, because it couldn't read beyond 26. What an evil bug. So we have to exclude that number. In the future I should create my own file format anyway. We let this loop search for the last pattern and add our pattern separator numbers that our algorithm will recognize and put its data there when we approach this pattern. Now we should be able to add new patterns to our song. Let's at first check the graphical user interface. As you can see, between 1.9 and 1b we excluded 1a. Let's add an print instruction in the encoder function again. We want to see what is going to happen to our code now that we can add new patterns. Tiny corrections, then we will start. As you can see, we added the docking points that our algorithm will acknowledge as starting points to each pattern in which we can write data. Now we should have everything ready to fill patterns with data. Before we can move on, we need a way to switch through patterns. So let's code 2 numpad keys into our process input. I have to admit that all these variables and conditions look like a mess. Okay, ready to go. Let's compile. We finally did it. Now we can focus thoroughly on the actual sound processing.